Solar energy has become the cheapest source of electricity in history, thanks to silicon solar panels. But silicon is reaching its physical limits. It is heavy, rigid, and expensive to manufacture. Today, we are exploring Perovskite Solar Cells, a revolutionary material that can be dissolved into liquid ink, printed onto flexible sheets, and harvest solar energy with unprecedented efficiency. Silicon solar panels have dominated for decades, but they have downsides. Manufacturing silicon requires melting quartz sand at 1700 degrees Celsius, which consumes massive amounts of energy. Furthermore, the resulting panels are heavy and brittle. Crucially, silicon is approaching its theoretical maximum efficiency limit of 29%. Perovskites represent a clean break from silicon. Instead of heavy glass plates, perovskites are thin, flexible, and lightweight. Instead of energy-intensive cleanrooms, they are printed from liquid inks at room temperature. This slashes manufacturing costs, reducing the carbon payback period of a panel from 2 years to just 3 months. The magic of perovskite is that it behaves like ink. Engineers dissolve perovskite minerals in a solvent, creating liquid solar ink. They feed this ink into roll-to-roll printers similar to those used to print newspapers. In minutes, the printer coats thin sheets of plastic with a uniform layer, producing miles of flexible solar film. To get the best of both worlds, engineers build tandem cells. They stack a layer of perovskite directly on top of silicon. When sunlight hits the panel, the top perovskite layer absorbs high-energy blue and green light waves. The lower-energy red waves pass straight through to the silicon layer underneath. This captures the solar spectrum far more efficiently. Standard silicon panels struggle to convert high-energy blue light, wasting most of it as heat. Perovskites are tunable, meaning we can change their chemical formula to absorb specific colors. By stacking a blue-absorbing perovskite over a red-absorbing silicon cell, tandem panels push theoretical efficiency limits past 43%. Because perovskite is flexible and can be made transparent, it changes where we can harvest solar. We can laminate transparent solar films onto windows, turning skyscrapers into power generators. We can integrate them into clothing, backpacks, and car roofs, allowing everyday items to generate electricity without heavy panels. The numbers show why researchers are excited. Tandem solar cells have already achieved laboratory efficiencies of nearly 34%, compared to 20% for conventional panels. Furthermore, because perovskites only need to be heated to 140 degrees, they require far less energy to produce. The big snag with perovskite is durability. The crystal structure is highly sensitive to moisture, oxygen, and heat. When exposed to humidity, the crystals can dissolve, turning the solar cell back into a useless liquid. While silicon panels are guaranteed to last 25 years, early perovskites failed in just a few hundred hours. Another concern is toxicity. Most high-efficiency perovskite cells contain lead. If a panel breaks or is discarded in a landfill, this lead could leach into the soil. To prevent this, scientists are developing lead-free alternatives using tin, and using advanced encapsulation layers to seal the lead inside, even if the panel is physically damaged. Commercialization is beginning. Oxford PV is shipping the first commercial tandem panels, while Hanwha Cells is investing $100 million to build tandem pilot lines. Initial rollouts will target industrial roofs, with flexible consumer films expected to hit wide markets by the end of the decade. Perovskites are poised to transform solar energy from a heavy, industrial technology into a flexible, printable coating. By boosting efficiency and lowering manufacturing costs, they bring us closer to a world where any surface can capture the power of the sun. What do you think about perovskite? Let us know in the comments below. If you want more simple science explanations, subscribe to Layman's Field, bringing knowledge for everyone. We will see you in the next video.